This video is just to give you a few more examples of using the exponent rules that we discussed in the previous video and simplifying. So let's just go ahead, we'll do 3 or 4 examples here and kind of move on from there. So let's look at the first one here. So example 1 here. So we're going to simplify the expression negative 5z all to the third power. So when we do this, that's using one of our exponent rules where we have a quantity to a power, so we apply that exponent to everything in there because what's going on inside is multiplication. Now this one, I always encourage you, I find people make mistakes here. This would be negative 5, notice I still keep it in parentheses there, to the third power, z to the third power. And then we simply go ahead and finish this out. Negative 5 to the third power would be negative 125 z to the third power. Okay, so let's look at another one here. Let's look at negative z to the third power times 3z to the fourth power. Now the first thing we should notice here is that I have a negative here. So notice the negative. So when I'm going to first use my first one, there's actually a number here because a negative is the same thing. I'll kind of write it in between here as having negative 1 times z. And so if we start to simplify this, this would be negative 1 to the third power z to the third power times 3 times z to the fourth. Now, not necessary to do this, but I'll take it in a couple steps here. Negative 1 to the third power is, of course, negative 1. So you'd have negative 1, and I'll write the numbers next to each other, times 3 times z cubed times z to the fourth. Now we just finish this out. Negative 1 times 3 is negative 3. Of course, what do I do to the 3 and 4? Well, the property says I should add those. So this would be z to the 7th power. So example 3 here. Let's go ahead and start off with a simpler one here. So 7x squared over x cubed. Well, this would be the same thing as 7 times x to the 2 minus 3, which is 7x to the negative 1. And then if I rewrite that with a positive exponent, this would be 7 over x. Now that's one way to do the example. Some of you might be familiar with another method, and let's just go ahead and go through that here. So if you have 7x squared over x cubed, some of you may remember a term called reducing, and what we can see here as well, if I cross off 2 here, I'd have 3 minus 2, I'd be left with 1. Cross off 2 here, I'd have 0, and of course x to the 0 power is 1, and so this would just simply be 7 over x, which of course is the exact same thing we got doing it the other way. I don't care which way you do these, they're both algebraically correct. Let's look at one more example here, and then we'll finish this up here. Let's look at well, I would say a involved one, but maybe just one that has a few more things we have to keep track of. So we've got a bracket, and then a parenthesis, x squared, y to the negative 2, to the negative 1, square bracket, to the negative 1. Now, I don't try and make negative exponents positive right away. I'm just going to go through and do the power of power rules that I have here. So notice that I have a to an m power, b to an n power, and it's all to another power here. So what this would equal here is this would be bracket, and then I'd have x to the 2 times negative 1, y to the negative 2 times negative 1, bracket, negative 1. And that's just distributing this negative 1 exponent in. So let's go ahead and simplify that. So I'd have x to the negative 2, and then y to the positive 2. This is all to the negative 1 power. And finally, we can finish this out by just applying the negative 1. And of course, I'll skip writing this step down, and we'll have negative 2 times negative 1, which is positive 2. So I'd have x squared, y to the second times negative 1 would be y to the negative 2. And finally, using our negative exponent rule, we'd have x squared over y squared.